Hi everyone, welcome to AI Crack channel. This is Akash Kumar and today we'll be studying circles lecture 2. So we'll be starting this lecture with circles under special conditions. So there are 5 cases in total. When the circle touches x-axis, y-axis, x and y-axis both, passes through origin, and circle passes through origin and has intercepts A and B. Okay. Now let's look at the first condition when circle touches x-axis. So it can be above it, it can be below it, but we'll take this condition for now. So we have center H and K and we have the radius R. Okay. Now in our general circle, we have three variables x square plus y square plus 2gx plus 2fy plus c equals to 0. We have the variable one that is c. This is second. This is third. C is basically corresponding to radius of the circle. So basically we have three variables, two coordinates of the circle center, and the third one is radius obviously. Okay, so we have these three variables and we have to we need actually three equations or three conditions to find out these variables. But over here is one condition is given in a hidden format. So we have this center H and K. Now if you look closely, you can see that this radius, length of radius is same as the K coordinate, because this length is same as the K coordinate and that is also R, right? So you can write K in place of R. You don't really need to put R and K separately. You can write K in place of R. Okay. So now we have just two variables, H and K. And with the help of two conditions only, our entire circle equation can be found out. Okay. So this is how you have to treat this case one. In this case, you'll be needing two conditions, two additional conditions, other than the condition that the circle is touching x-axis. So that is also one condition. Other than this condition, we need two conditions more to find out the variables h and k to finally find out the equation of circle. Okay. Now let's look at the second case. Second case is exactly similar. So we have a circle which is touching y-axis. Now in this case, if the center is h and k, now radius would be h, because this x distance is nothing but the h coordinate and that is also equal to radius. So again we need two more conditions to find out the equation of circle. Now the third case is the circle is touching both x and y axis, right? Now in this case, let's say if this is h and k, now this should be h and this should be k, right? But we know that radius is equal, both radius should be equal because they belong to the same circle. So eventually we have just one variable, let's say h only. So we can write the center as h comma h and radius is also h. Okay. Now two conditions have already been utilized. The first is touching y-axis, second is touching x-axis. We just need one more condition to find out the h variable and basically to find out the entire equation of circle. Okay, so this is our case 3. Now the fourth case is the circle is passing through origin. Now in this case, the general equation is x square plus y square plus 2gx plus 2fy plus c equals to 0. Now if it's passing through origin, you can put the value 0 comma 0 over here. You will see that c comes out to be 0 because this is having x, this is having y, this is x, this is y square, this is x square. If you put 0 over here, you will get c as 0. So in such a condition, we can directly write the equation as x square plus y square plus 2gx plus 2fy equals to 0. We can directly write the equation of circle like this. So we have two variables here and we need two more conditions to find out the equation of circle. So this is our case 4. Now let us talk about the case 5, where circle is passing through origin and also making intercepts a and b in x and y axis respectively. Okay, this is our origin. Now interesting thing over here is coordinate axes make 90-degree with each other, and if I join these 2 points, I can clearly see that this is a right angle triangle, and right angle triangle forms in a case when these 2 points, let's say this point is capital B, this is A, when this AB is the diameter of this circle, right? Only in that case this can be 90-degree, right? Now if we have got the diameter and since we know these intercepts A and B, basically we know the coordinates of A, so that would be A comma 0, and over here it would be 0 comma b. So if we know the coordinates of diameter, we can write the equation of in the diameter form, right? So that would be x minus 0, x minus a plus y minus 0, y minus b equals to 0. So we can also write down the equation of circle in the diametric form, right? So basically in this particular case, we already had three conditions. The first condition is this condition that this intercept is being given. Second condition is this intercept is being given. The third condition is the circle is passing through origin. So we already had three conditions given. So that is why we can directly find out the equation of circle from these three given conditions. So this is our case 5. So you don't really need to remember these things. It's for the just demonstration purpose that how should you approach to find out the equation of circle when certain conditions are given, whether it's touching x-axis, whether it's touching y-axis, whether it's touching both x and y-axis, whether it's passing through origin, or this particular case. You should be understanding the basic concepts that you should be needing three conditions minimum to find out the equation of circle. Okay. Now let us look at this question. The equation of the circle passing through 3 comma minus 6 and touching both the axes. So this is our third case, right? Let's see how to do it. So first of all, we'll locate this point 3 comma minus 6. This is, let's say this is 1, 2 and 3 units, and 6 units downside should be somewhere over here. So the circle is basically passing through this point 3 comma minus 6. So basically we have to consider the center of circle somewhere in the fourth quadrant. There is no point in considering the center of circle in the first quadrant or second or third quadrant. We should be considering our center of circle in the fourth quadrant because it would form a circle something of this sort, right? Common understanding. So let's say our center of circle over here, and let's say this radius is r. Length of radius is r. The important thing is length of radius is r, not the coordinate of radius. Length of radius is r over here. So basically r is positive. And if we are taking the point in the fourth quadrant, so basically we should be considering the center as r comma minus r because r is positive. Okay. So that is why we should be considering r comma minus r. In the demonstration for the cases, we took the first quadrant. That's why we took h comma h. But in this case, since we are talking about the fourth quadrant, we should be considering r comma minus r where r is positive and that is radius. Okay. So now we can write down the equation of circle as x minus r whole square plus y minus r whole square equals to r square, right? And since this circle is passing through this point, we can put this value in this equation, right? That should satisfy. So we have 3 minus r whole square plus minus 6 plus r whole square equals to r square. So this gives me r square plus 9 minus 6r plus r square plus 36 minus 12r equals to r square. This r square gets cancelled out. We are left with r square minus 6 and minus 12, that becomes minus 18r, and 36 and 9, that becomes 45 equals to 0. Now if I do the factorization, I'll be getting r minus 15 and r minus 5, r minus 3, okay, equals to 0. So we're getting r equals to 15 and r equals to 3, or r equals to 3. Okay, so these are the two possible values of radius. Now how to visualize it? We thought the circle would look something of this sort, but one more possibility is there that a bigger circle can form of something of this sort, like it's touching the x-axis over here and y-axis over here, and it's forming a big circle. That is why the radius is 15 and this radius is just 3. So radius just 3 is this one, and the radius with 15 is the bigger one. Okay, so we have these two answers. Now you can just plug the value of r over here and you can find out the two values of equations over here and match the options. Okay. Now let's look at this question. Circles touching x-axis at a distance 3 from the origin and having an intercept of length 2 root 7 on y-axis r. So before starting this question, let's talk about the concept of intercept in case of circles. So if we talk about the x-intercept, so when a circle cuts the x-axis, then this distance is called as x-intercept. And when the circle cuts the y-axis, then this distance is called as y-intercept. Okay. It can be positive on the positive side, on the negative side, but this is how the intercept is being defined. Now this question has an interesting twist over here. So it is saying that distance 3. So basically it's using the word distance over here, and over here it's using the intercept of length 2 root 7. So we talked about this in AOD and straight lines. When we talk about just intercept, if we say intercept equals to 5, that means that is the positive 5. We will be taking on the positive x-axis or positive y-axis. But when we are saying intercept of length 2 root 7, that means it can be either on positive side or on the negative side, because length is not negative. Okay, length is doesn't include the signs. Length is just the magnitude. So basically, it's saying that the magnitude of intercept is 2 root 7. It can be on the positive side or on the negative side. So basically, sorry. So it can have 2 root 7 over here or 2 root 7 over here. Similarly, distance 3 from origin, it can be either on the positive side or on the negative side. So basically, it will be having 4 cases, but we'll be considering just one case, and you can solve the rest one similarly. So let's talk about the first quadrant case over here. So we have this circle, and this distance is 3, 0. So basically, circle is touching at this particular point. Okay. Now the circle is forming like this. Okay. And let's say this is the center. This distance is 2 root 7. Now we know that radius is perpendicular to tangent. Okay. At this particular point, radius is perpendicular to tangent. So basically, the center is also having the x coordinate of 3 and y coordinate of radius, because this is touching the x-axis. So this is radius, and this y coordinate should be equal to radius only. Okay. Now this is also equals to radius, and this distance is 3, right? As given in the question, this distance is 3. And we know that because of the symmetry, we can clearly say that if this distance is 2 root 7, this entire distance is 2 root 7. And if we are dropping a perpendicular over here, so this distance, because of the isosceles triangle, this distance would be root 7 only. So from here to here, this distance would be root 7 only. So we have root 7 over here, we have 3 over here. We can apply Pythagoras to find out the radius, right? So r square equals to root 7 square plus 3 square. That would be 7 plus 9, 16. So r equals to 4. So radius is 4. We have got the radius as 4. Now we have got the radius. So basically we have got the center coordinates as well. So the center coordinates are 3, 4. Now you can find out the equation of circle easily. X minus 3 whole square plus y minus 4 whole square equals to 4 square. So this is the equation of our circle. So I think the answer would be option C. Now let us talk about position of a point, and from here onwards we'll be introducing one notation called S, and that would be very important for the entire conics. We'll be using that notation in the conics, other conics as well. That is basically parabola, ellipse, hyperbola, and that you should be remembering. So before starting with that notation, let us understand the concept of position of a point. So we talked about position of a point in case of lines as well. In case of line, it was with respect to a line, right? And this, if I put this value in this equation, line equation, and if I put this value in this line equation, both of them would fetch opposite values of opposite signs, right? So that was the condition over there. Now let's see how we develop the position of a point in case of a circle. So let's say we have a standard circle with center at 0, 0 over here and radius r. Okay. Now there are 3 points. This point is P1, and there is one point called P2 on the circle, and there is one point called P3 which is inside the circle. Now the common sense says that if this point is P1 is outside the circle, so basically this distance CP1 should be greater than r. If this point is on the circle, CP2 should be equals to r. If this point P3 is inside the circle, CP3 should be less than r. This is the common sense, right? Now, how to use this common sense to form a generic equation for position of a point? Okay. So let's say the coordinates of all these points are x1 and y1. All these points, okay. These are the variable points x1 and y1. Now, if we take the first condition where this point is outside the circle, so basically CP1, that is this distance, that would be, so basically under root x1 square plus y1 square should be greater than r. That is what we mean by CP1 is greater than radius. Okay. Now if I square it both sides, we know that under roots are always positive, radius is positive, we can square it and without changing the sign. So basically if I square this equation, we'll be getting x1 square plus y1 square greater than r square. Now if I take this r square towards the left side, I'll be getting x1 square plus y1 square minus r square greater than 0. So this is our condition. Now if I take the second condition where I'm talking about CP2 equals to r, I'll still be getting x1 square plus y1 square minus r square equals to 0. And the third case we'll be getting x1 square plus y1 square minus r square less than 0. So this is giving me a hint that what I am doing, I am putting the value of x1 in the circle. By taking r square towards the left side, I am putting the value of x1 and y1 in the circle and just comparing the values with respect to 0. If it is less than 0, that basically means the point is inside the circle. If it is equals to 0, that means point is on the circle. If it is greater than 0, that means point is outside the circle. So that is actually very simple to understand, right? Now we see this particular term x1 square plus y1 square minus r square. Now from now onwards, we'll be doing S note. We'll be talking about S notation. Okay. So S is equals to x square plus y square minus r square. So what we actually did, this is common for every conic, be it circle, be it parabola, be it ellipse. It's common for everyone, every conic. So let's say I have the circle x square plus y square plus 2gx plus 2fy plus c equals to 0 or plus c equals to, let's say, k. What I'll do to write the S. Now S over here would be x square plus y square plus 2gx plus 2fy plus c minus k equals to 0. So this is our k. This is our S notation. Now if I put the value of this point over here, x1 y1, that would become S1. Okay, that would give me x1 square plus y1 square plus 2gx1 plus 2f1 2fy1 plus c minus k. Okay, now we have to compare this S1 with respect to 0. If it is less than 0, basically point is inside the circle, equals to 0, point is on the circle, and if it is greater than 0, point is outside the circle. So be it any conic, as of now we're just talking about this circle only, and this condition is for circle only, but we'll be using this S notation for other conics as well. So you have to remember how to form the S notation, and we'll be utilizing this S notation for many other conditions. So that was the first condition which you should be remembering, that in such a case S1 is greater than 0, that means point outside the circle. S1 equals to 0, point is on the circle. S1 less than 0, point is inside the circle. So this is the condition which you have to remember. S and S1 notation, very important for conics perspective. Okay. Now let's talk about this question. How many tangents can be drawn from the point 5 by 2 comma 1 to the circumcircle of the triangle with vertices 1 comma root 3, 1 comma minus root 3, 3 comma minus root 3. Now first, let's plot these points. And as I've said earlier I think in the previous lecture, whenever you see 3 points, the first thought should not be of x square plus y square plus 2gx plus 2fy plus c equals to 0. And now I'll be putting these 3 points and getting 3 equations in 3 variables in g, f, and c, and then solving them to find out the equation of circle. You don't really have to do that in most of the cases. The first thought should always be to plot these points first, see if this is forming a right angle triangle or an isosceles triangle or an equilateral triangle. That would make your life simpler. So first of all, we'll plot these points. Okay. So 1 comma root 3. So 1 is somewhere over here and root 3 somewhere over here. So this is 1 comma root 3. Okay. 1 comma minus root 3. So that is exactly opposite. 1 comma minus root 3. And 3 comma minus root 3. So that would be 2 units away. That would be somewhere around here. 3 comma minus root 3. Now I can clearly see that these 2 points are having common x coordinate. So that means this is a vertical line, a line perpendicular to x axis, and these 2 points are having common y coordinate. So that means this is a horizontal line that is perpendicular to y axis, right? So that means this point is having a 90-degree angle. So that is, it's a right angle triangle, right? And when it is a right angle triangle and the circle is passing through all these 3 points, so basically these 2 points are the diameter of the triangle, diameter of the circle, right? The circle would look like something of this sort. Now, and when we know the diameter, points of the diameter, we can write the equation of circle in the diameter form, right? So that would be x minus 1, x minus 3 plus y minus root 3, y plus root 3. So this is the equation of our circle equals to 0. And now we have to see how many tangents can be drawn from the point 5 by 2 comma 1 to the circumcircle. Now we have an external point somewhere over here. Let's say this is 5 by 2 comma 1. We don't really know if this is point external to the circle or it is internal to circle. We don't really know. How can we do that? We'll write S notation over here. Now, since we don't have any constant over here, S notation would be this only. S would be x minus 1, x minus 2, plus y minus root 3, and y plus root 3. Okay, this is RS. Now we have to write the S1 notation and check if it is greater than 0, if it is equals to 0, or if it is less than 0. And if we check it, we can see that S1 comes out to be less than 0, then it's inside a circle. If you see that if it's equals to 0, it's on the circle. And if it is greater than 0, it is outside the circle. And that you can do easily. So just you just have to plug the point 5 by 2 comma 1 on this equation, in this equation, and you just have to compare it with 0 to find out the answer. Okay. Now, if the point is actually outside, so basically if S1 comes out to be greater than 0, in that case we'll have two tangents. If it is on the circle, if it comes equals to 0, that means we have just one tangent. If it is coming inside the 0, that is less than 0, in that case we don't have any tangent from that point on the circle. Okay. So today's lecture was till here only, and I've tried my best to solve the questions with the help of only basics, no fancy formulas, no standard formulas, because you won't be needing those formulas in the actual examination. They are not going to ask you very standard questions, and neither too difficult questions that you have to use very advanced concepts. Okay. So only thing you have to focus in on the basic concepts, and that would solve all your PGDBA problems related to circles. So let's meet tomorrow. Thanks for watching.